In this video, I'm going to show you how to get Let's Encrypt SSL certificates working with AWS. So Let's Encrypt is a free certificate authority where they give free SSL certificates. And usually what they do is they provide a command line utility called Certbot, and you run that and generate certificates. And it has auto renewal as well, so that every 90 days before it expires, it renews the certificate. That works great in a VPS environment where you have full control of the instance. However, if you're using something like Elastic Beanstalk where Amazon is managing a lot of other cloud services together, it becomes a little more difficult because that instance is going to be destroyed and recreated every time you relaunch your application. AWS does provide free SSL certificates. However, it requires your application to have a load balancer, and load balancers aren't available in the free tier. So this is an alternative if you want to keep everything free. The basic structure is you have a Lambda function running every 90 days, generating a certificate, and then uploading it to an S3 bucket. And then your application can access the certificate from the S3 bucket, and during the build phase of your application, you can attach the certificate. This is a new Elastic Beanstalk application. It has the sample application loaded onto it, so if I go to the URL here, this is what it looks like. The first thing you have to do is have a domain associated with your application. Route 53 doesn't have to be your registrar, but it does have to host your domain. What that means is you can buy your domain from anywhere, but it has to be hosted in Route 53 so that when your website is looked up, it is going to Route 53 to point to your application. The reason for this is our Lambda function is going to be running Certbot, and there's a plugin for Certbot that modifies DNS records in Route 53 to properly authenticate your domain and issue you a certificate. Alright, so now we're going to create a programmatic user to be used with the AWS command line interface. So let's go to IAM. Okay, go to users, we're going to add a user. I'm just going to call this Joe Codes Dev 01. Programmatic access, we don't need access to the console because we're just using the CLI. You're going to need AWS CLI installed. So I won't be showing you how to install AWS CLI, but there is thorough documentation on that. Now you can type in AWS configure profile. I'm just going to call the profile the same thing as the user. Then it'll ask me for the access key. I already copied, but I'll copy it again. Put it in there. Secret. Region. And then this is the region where everything's going to be. So in my case, I had it on US East 2. So this is where your Elastic Beanstalk application is. Output format doesn't matter to me. Alright, so now we have that user available to us to use. So the next thing we're going to do is we're going to create an ECR repo. So Elastic Container Registry is where container images are stored in Amazon. And our Lambda function is going to be built from a Dockerfile because I find that the easiest. So let's go over there and do that. Okay, let's create a repository, get started. Okay, it'll be a private ECR repository, and we'll call it Joe Codes Test Application. Alright, that's everything. Create it. Now we want to create the S3 bucket where the certificate will be uploaded to from the function. Go to S3. So Elastic Beanstalk provides a bucket for you already. You can just upload it to that bucket if you want. However, I like to keep things more separate, so I'm going to create a new bucket for that. I'm going to call it Joe Codes Test Application. Okay, we can block all public access. We don't need any public access for this. It's all going to be interacted with the user that we created. Alright, so now we're going to build the Lambda function Docker container. So this is where the certificate is going to be generated. So I have the base Dockerfile here. So this is just grabbing the Python base image from Amazon. Then it is going to install with pip the Certbot with the DNS Route 53 plugin. So this is what's going to be authenticating your domain to issue the certificate to you. And even though this seems like it's only installing the plugin, it's also installing the base Certbot. So you don't need to install both Certbot and Certbot DNS Route 53 because this comes with both programs. Then we will copy the Lambda function into the container and then we will run it. So this is the Lambda function itself. We need JSON for web requests. We need the Certbot for generate the certificate. We need OS for some basic IO, file searching and such like that. And then we need Boto3 to access the Amazon S3. So I've created some globals here. They don't have to be globals. You could have put these inside the function, but I just wanted to keep it more concise and more obvious on what you need to enter. So you need your email here. This is something that Certbot requires. Then we have a working directory. We're just going to do everything in temp. And these are the two domains that you'll be generating the certificate for. The www prefix is treated as a separate domain, so you need both of these. And for bucket, you put in the name of the S3 bucket that you created. And for the region, you put the name of the application region. And then the key is the subfolder within the bucket that it will put the SSL certificate into. So in my case, I'm just putting SSL. So now what we need to do is build the Docker container and then push it to the ECR repository that we created earlier. So to do that, I have a push to ECR script here. And what you do is you build the application and then we're going to tag it just to be consistent with the name of our repository. And then you need to tag it with the ECR domain prefixed with your account ID. So the way you get your account ID is you can click on your name up here and it'll show you my account and it'll give you your account number. Alright, so what we're doing is we're building the application, then we're tagging the application with the repository, and then we are pushing the application to the repository. I have multiple AWS profiles on here, so I will export this variable to set the desired profile to the correct user. So now what we have to do is we have to allow Docker to push to the ECR. So to do that, we do something called get login password. This will generate a token and give it to us. So I'm just going to copy this straight from the AWS docs and then change the required fields. So over here, so now we properly authenticated Docker with AWS. So the way that worked is it generated a token with our AWS profile we had created earlier, and then it authenticated Docker that way. So now we can build the Docker container and push it to the ECR. So let's just run the script. Okay, and it is pushing now. Okay, so the push has succeeded. So if we go to the ECR here and I click here, see the latest image. And here it is. This is the latest image. So it worked. So the next thing to do is to create a Lambda function instance that uses this Docker container. So let's go to the console again and we'll go to Lambda. Let's create a function. We're going to do container image. Okay, function name. We'll call it Joe Codes test application generate SSL. Okay, container image URI. Let's browse here. We'll click on our repository. We'll click on the latest image. It might be better to name the repository after what the container actually does, which is generate the certificate. But I'll ignore that and continue. Alright, now we can create function. Before we continue, I just want to make a note about the Lambda function that I provided. So inside the function here, Certbot has a function called dry run, which I've added to one of the parameters. And what that does is run through the process of generating a certificate, but it doesn't actually issue it to you. So this is just to make sure that everything's working correctly before we actually issue the certificate, because there are quotas for how many certificates you can generate and renew in a week. So at the moment it's 5. So if you get this incorrect and it generates a certificate and everything's working but it fails uploading to S3 or something like that, then you lose one of those renewals for the week, but you don't actually have the certificate with you. So in order to avoid that, to make sure everything's working correctly, we're going to add the -dry-run to the certbot, and then we'll make sure that everything is working. Then once we've made sure that everything's working, we're going to go back, we're going to rebuild the Lambda function without the dry run, and then we're going to run it again. Okay, now we just need to configure the Lambda function. We just need to change one thing, and that is the execution time. So let's go to this new layout for me. Here, timeout. Okay, so go down to timeout. And it's going to take a little longer than 3 seconds, so we need to change that because otherwise it'll just cancel the application. Let's make it 2 minutes. Lambda functions can run up to 15, so 2 minutes is still very minimal. Save that. Once the function is created, we need to go back into IAM and we need to create a policy and attach it to the function that allows it to edit records in Route 53 so that we can properly authenticate our domain. Alright, so back in the application, I can see in the configuration what the role is. So I will just take note of this here, and this is the role. This is from the previous test. So I'll click on the role here, and we need to attach a new policy to it. Attach policy. We're going to create a new policy. And from the DNS Route 53 documentation here, I'm just grabbing this policy that it provides with us, and we'll put that in as the template. So let's go to JSON format. We'll paste that in. Okay, so it just needs to list hosted zones. It needs to get the change. It needs to change record sets. Okay, so let's go to your zone ID. And what we're going to do is actually put that ID in. And we'll go to Route 53. Okay, you go into the hosted zones, and then with the domain you're using, the zone ID is just on the right here. We're going to copy that. Put it in the policy. Make sure there's nothing else we have to edit. Okay, we're going to go to next. Review. Now we need to name the policy, so I'll call it Certbot DNS Route 53 create policy. Okay, now that we've created the policy, we can attach it. So I just went back to the IAM role information for the Lambda function, and let's search for the role name. So I called it Certbot DNS Route 53. Attach that policy. So now we need to attach a policy that allows the Lambda function to upload to S3 so that we can actually upload the SSL certificate. So we're going to go to attach policies here. And we're going to just see the S3 roles. Again, in production, you're just going to assign the permissions that are required, but for this example, to make things simple, I'm just going to give it full access. Okay, so that policy is now attached. I'm going to go back to the function, go to test. Okay, we're going to send an empty object. I just named it test. I saved the changes, and let's invoke it. Okay, so it is successful. That means that everything is working. Now let's actually generate the certificate. So I'm going to go back to the Lambda function. Okay, and I'm going to remove the dry run. And now this is going to be the real deal. So if this messes up, then it's going to count towards our renewals. And hopefully we can fix the issue before we run out of renewals. I'm going to rebuild the image. Okay, and now we're uploading it to the repository. That's done. It's quick. So we need to rebuild the Lambda function now. So we're going to go to image, deploy new image, browse images. I'm going to pick the repository again. I'm going to pick the latest image tag, select image, save. Okay, and this will take Very minimal amount of time, probably 30 seconds, and then the new image will be built for the Lambda function. Okay, so now that the Lambda function is done building, we'll go over to test and we'll invoke it again. Let's go to the S3 bucket and see if it actually worked. And we actually have the certificate generated here. So now to use the certificate, all you need to do is in the build phase of your application, whether you're using Docker or any system, what you do is you just pull the certificate from S3. It has nothing to do with the issuing or the renewing of the certificate. You're just pulling the certificate that is available in the S3 bucket. Now for renewal, because this will expire in 90 days, what you can do is you can use CloudWatch. So we can go over to CloudWatch. Okay, we'll go over to events. We're going to get started and we're going to create a schedule event, fixed rate of 90 days. You can make this 85 or slightly under. I like to do 85 because then if something goes wrong, then you'll have a means to renew the certificate before the expiry, which is 85 days. Okay, now you want to make sure that before you create this rule, you want to make sure that you're in the correct region. Otherwise, you won't be able to access the Lambda function. So you need to be in the same region as your application Lambda function. So I set it to US East here. I'm going to add the target. We're going to select our Lambda function here. Okay, let's go to configure details, name, call it Joe Codes test application cert SSL renew. All right, now we can create the rule. Okay, great. So that's pretty much it. So now we've created a CloudWatch event that will run every 85 days, which will run the function that generates the certificate and then uploads it to S3. So every 85 days or so, the S3 bucket will be updated with the new certificate. So the application doesn't have to worry about any of this renewal. The application will just pull the certificate that is available in S3 bucket and use that. So if you're using Elastic Beanstalk, what I would do is make sure that it's running on a Docker environment. And then in Docker, when you're creating the container, I would install the AWS CLI and make sure that the role associated with that is authenticated to read things from the S3 bucket that the SSL certificate is in. And then you download the SSL certificate from the bucket inside the Docker build phase, and then the SSL certificate is placed in the correct configuration file, depending on what you're using, if you're using Nginx or if you're using Apache. To give you a working example, this Elastic Beanstalk application is using Docker, so inside the build stage of the Dockerfile, I have it installing the AWS CLI, then configuring the AWS CLI to use the correct programmatic user that has permission to access the S3 bucket. Then it uses the AWS CLI to copy the SSL certificate into its working directory. Then in the production stage, what it does is pull from the build stage the certificate and put it in the correct Nginx configuration file where the certificates are stored. So that was how to get Certbot working with AWS. I hope that didn't seem too overly complicated. I hope you learned something. Thanks for watching.